What? I just don't have any ones in my wallet, and I know I'm gonna forget. So I was thinking about giving too much money, and then. But not today.
Do you know?
Instead of hurrying back there, how about we get going on some math? Come on, Meow. Those three. Okay. All right. Pay close attention to where there are and are not parentheses. There we go. Nice and big. Okay, if we're mutating our axes to make it work for us, it should be pretty quick. Is anyone still going? Negatory? Awesome, Reggie. All right. Arctangent. Normally, boop, 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 would have a graph kind of like this. Almost look like a cube root. Normally, I would have 1, 0, -1. Take that back. Put you over here and here. Yeah, no, we're right. We're tired, but we're right. Okay. Because the arctangent of 1 is at pi over 4, you're going to line that up with halfway to your asymptotes. Asymptotes are horizontal now instead of vertical because it's the inverse function. And that is the parent graph. What I'm going to change, because we've got a +2 on there, means all of these on my vertical axis are going to go up 2 units. Now I could take the whole works, and what is pi divided by 2? Well, pi is about 3.14159 blah, 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 divided by 2. So about 1.55. So that means this is about 0.77-ish per box. If I need to go up 2, then I would have to go up almost 3 boxes. And everything would be in kind of a weird position. Or I can just call this 2 and say that's 2 plus pi over 2 and that's 2 minus pi over 2. So much easier. But you do have to be aware of how you're going to fit that to other axes, because that is how you'll do it in the future once you head to regular trig class. Okay? If the b value is 1/2, remember that it's always a horizontal dilation by the reciprocal. So if your goal is right here and then we cut your input in half, it doubles the space until I get there. So I change these to 2 and -2 instead. The big catch is you have to make sure, do you have these points? Do you have 2? And then this will be halfway in between, so this will be 2 plus pi over 4. Okay? Because we can't just wing it a graph in between asymptotes and not really describe where the points are. It has to be proportional. Okay? So the things we're looking for are your vertical axis. I'm going to say 2 points. One for you had the correct spacing to begin with the asymptotes, and this was halfway through, this was halfway through. Have your x-intercept, or in this case it'll not be an x-intercept, but you get what I mean. The pi over 2 business, the asymptotes of the normal parent function, and then did you label them as compound numbers? Did you handle the horizontal dilation correctly? I'm going to specifically ask that you have those points there, because that's what makes it a proportional tangent graph, or arctangent. And then, did you actually have an arctangent on there? Or did you oops and make a tangent instead? Did you oops and, God forbid, I don't know, maybe you made a secant graph instead? Okay, so arctangent, base function, horizontal dilation, vertical dilation, regular graph, you have your asymptotes. Cool? Okay, so yesterday was mostly about talking about what inverse functions are and how to graph them. What I did not include in the assignment was, oh no, we don't want to go that far. You gotta be like way down here. There you go. Yeah, that's where we left off. What an arc function is, got our fourth commandment of domain, and talked about graphing them, and now we do finish it off with the applications of them. What's probably going to happen is we'll finish off 4.6, go straight into 4.7. We'll do the basic version of law of sines today. We'll get the ambiguous case, double triangle, no triangle business tomorrow during our shortened class, because early release, only an hour. And then we'll finish off law of sines and cosines on Thursday. If we have any time left over on Thursday, I'll just cut it off there so we can start fresh on Monday after our quiz. Cool? All right. So, applications. This is just an application of the arc function where you're trying to find an angle. Movie theater. Okay, a person's viewing angle. When they say a viewing angle, there's a big difference between the maximum viewing angle and the optimum viewing angle. Okay? Now think about if the screen is up here, you don't really care if you can see all the way to here, right? You care about seeing the screen. You don't really care about the little stage and curtains underneath it. If you got other stick figures in front of you, well, you don't really care if you can see the back of their head. That's not a part of your viewing angle, right? What they're trying to do is maximize the viewing angle, maximize the amount of the screen that fills your vision. Anyone who's ever had to sit up front knows that that is not optimal, right? Have you ever sat like in the first third of a theater and there's like a fight scene or a car chase scene? You can't even tell what's going on. It's just a bunch of blurry movement in front of you, okay? But apparently this person just wants the entire experience of filling their entire vision, okay? Remember the donut problems? Right? You take the whole thing minus the part you don't care about. Well, if you can see all of this, but you don't care about this, then big part minus little part, right? So now we're back to right triangle trig, because we find angles with arc functions. So riddle me this. How would I find this whole angle? Think back to right triangle trig. Opposites and adjacents and hypotenuses. What kind of measurements do we got? Okay, I've got the two side lengths. We have the screen is 8 feet off the ground. It's 32 feet tall. So grand total of 40 feet. But so the triangle I'm really looking at here is this. So I have an opposite of 36, and we're trying to find the distance that will maximize the viewing angle. We're going to need our graphing calculators for this. Okay. The tangent of theta 2, so finding that big angle, is going to be 36 over d, right? So the angle, think arc functions, would be what? The inverse tangent of that. That would get me the big angle. If I want to find big angle minus little angle, then I'm going to need, come on, green. I'm going to need arc tangent, that's a tin. Tangent, right? I'll need arc tangent of 36 over d minus, okay, how do I get rid of the little angle? This guy. Look at the itty bitty triangle. What's the opposite this time? Just 4, right? That 8-foot space, 4 of it is unseen because of stick figure Sally in front of you. So we'll do arc tangent of 4 over d. And that will get me the part that I actually care about. Now, I'm going to have to dump that into my calculator because it says to maximize it. You remember when we had our polynomials and they'd say something like, this polynomial models the amount of sales of blah, 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 maximize your profit. Right? You would dump it in your calculator, get a reasonable window, and then go find the maximum. Before we do, we're talking about maximizing the viewing angle. How do you want your angle? Do you want it in radians or degrees? Because I didn't see anything up here about pies and radians, so you get to choose. Like the typical person, are they going to understand that my field of vision is 5 pi over 6 radians? Or they're going to understand my field of vision is 150 degrees. Okay? So we'll probably go for second plus 7, enter 2. We're going to just reset the whole works. What does it always default to? Radians. So I want to go to mode. I'm going to switch it over to degrees because most people are going to understand if I say 180 degrees, 90 degrees. Okay? Then we go to y equals. We're going to type that in. Obviously, I don't have d as a variable on here, so I'll just put x. We're going to have an arc tangent of, what was it, 36 over x. We'll take away the little bitty sliver that we don't care about, arc tangent of 4. Right. Over x. Close parentheses. Okay. Now, if I hit graph right now, I'm not going to see too much because my input is distance away from the screen. My output is the angle that I can see. This is 10 by 10. So that would mean I'm only about 10 feet away from the screen, and I can only see 10 degrees of it. That doesn't make too much sense, okay? That'd be like for me to here trying to look at what's on Lori's phone. So I need to make that bigger. Go to the window and what do you think is reasonable? Y'all been in a theater? How far back do you think we might sit? 50 feet? 20 feet? 100 feet? 300 feet? That ain't right. Okay. I like starting with 50, and if we need to change it, we'll change it. Because remember, you want to fill your vision with this screen. You're probably not sitting at the back of the theater. Okay. Y's. What do you think is a maximum viewing angle? Like, think about just sitting in front of a TV screen, sitting in front of your computer monitor. How much of your vision does it actually fill? How much can you see? Like, hold your hands straight in front of you, and then staring straight ahead. How long until you can't see your hand anymore in your peripheral vision? Mine's about there. What is that angle? Look like a big alligator here, right? Okay. Everyone's like, okay. So probably not up to 90, right? That's probably overkill. So I don't know, maybe I'll go 60, partway between 45 and 90, and just hope for the best. All right, what do we got? Come on, Frank. You can do it. Said that streaming software just slows these things down like you wouldn't believe. Could you imagine getting all the way to the top of that roller coaster and then tink, 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 tink? Okay, so I do see a maximum, right? How do we find it? Yep, just like the good old days. Second calculate, go find your maximum. Never thought you'd want to go back to polynomials from Algebra 2, right? And, I don't know, what was that, like 30? As long as I'm between those two things, whoop. And now I can find my maximum viewing angle. Now remember, this isn't going to be optimum. Have you ever filled your entire vision with a screen? You're probably a little kid and got yelled at by your parents about sitting too close to the TV. Okay? What does this say? What is this in the context of the problem? 12 what? We're finding distance, right? This was in feet. If you sit 12 feet away from the movie screen, go to the theater and sit 12 feet away from it. You will be able to fill 53 degrees of your viewing distance. Okay? I don't know if you'd even be able to tell what's going on because the rest of the theater is all the way out to your peripheral vision. So it may be the most, that doesn't mean it's optimal. Everyone knows that you sit about 2/3 of the way back. You spread yourselves out. You got to be not direct center because you're going to have some idiot in front of you. You got to be a little bit off center. Okay? So our answer is 12 feet back, we're going to have a maximum viewing angle of 53 degrees. Okay? So you can do the same thing. Oh yeah, and going back to the old notes here, we've got a typo. We have Tuchus. Tuchus, not Lucas. Tuchus. So stick figure Tuchus is going to be watching TV. Go find his optimum distance, or not optimum, his maximum viewing angle. What distance is he from the TV? Okay?
Yeah, did you ask how? Oh my goodness, look at mine.
Come on now, do the thing. You don't have to draw the stick figure. Just do the problem.
No, do you remember them? You can't cross it.
They're being very respectful. All right, juniors, this is purely for my own knowledge. Is it all kindergartners are coming up here to do the slime thing? Okay. But is it every class from Mountain View is coming over here, or just some of them? Okay. Because I had an argument with my 5-year-old last night that you just have to wait your turn.
I don't know how to draw. I drew it right. I don't know how to draw it.
You're going to draw this exact same triangle setup. It's just going to have different measurements over here.
How come mine looks so different? Because you were...
Because they have it flat like this instead of like this.
So where's the big triangle from the graph?
All right.
I really hate directing. You really hate it. I just wanted That's how you do it. Yeah, that's exactly what mine is. Well, how come mine's so tall? I don't know. I don't want to erase it.
Okay. Set it up just like the last one. It's just got different measurements. Oh, you're going to be pretty close. I would not be surprised if he's like 2 feet away from this thing.
What is that little one? The purple line. What the heck is that?
To the bottom of the TV.
Mine just doesn't look right. I have 3 and 5, 6.
So 5, 6, 1, 2, 4, 8, 3, 9.
Oh, I don't know how to do this. I don't. What's 7.5? Yeah. No, yeah.
Wrong one. That way. There we go. Okay. So the entire thing, how much vertical distance can Tukas see? Well, TV's mounted 7.5 feet up, 2.5 feet tall, grand total of 10 feet, minus 3 because that's their eye level. So 7. And then, if the TV itself is 2.5, then what's the part we don't care about? Whole thing's 10. We don't care about bottom 3. So the part he doesn't care about is 4.5. And then we've got our distance again. We've got our 2 angles. Whoa, 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 get back here. There we go. We've got theta 2. And we'll subtract theta 1 that we don't care about. It's going to be arctangents again. Not always, but you found out when we were doing angles of elevation and depression that they really like using tangents because that's horizontal and vertical distance. They're easier to measure than a kitty corner diagonal distance. So arctangent of the whole thing, 7 over x, minus the arctangent of the part I don't care about, 4.5 over x. And just for a comparison, since I've got it right here anyway, I'm going to put that into y2 just so we can see Tucus here versus the movie theater. Not Tucus. Tucus. Okay. Seven over x, close, minus arctangent of
Yes, boss.
there you go.
See, this is why I'm not bringing food to keyboard.
That was
I had to live through that era. How dare you bring me back to that?
excellent. Excellent. Poor doctor.
I'm reading about snow trapped in a traffic light. You're doing soccer related.
Hey, he actually.
So I'm going to calculate a maximum. If I have 2 graphs on here, do you remember how you go to the other graph? Arrow down. And we'll be from 1 to 8. Ain't gonna be that far. There you go. Thinking. I'm thinking. Come on, Frank. You can do it. What did you say it was? 5 something? Okay. Yeah, Frank gonna take a sweet time. You get the idea, right? It's just an application of arc functions. Okay. So, optimum viewing angle, though, only 12.5 degrees. 12.5 degrees is like I can see this. 2.5 feet tall. I mean, that's meh. So that would be like, what, 40-inch mounted on the wall? So. All right. So those are some applications. Yeah, we got it. Blah, 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 do the thing. Okay. Now, yesterday, when we were talking about finding these arc functions. Remember, arc functions are restricted. Where is sine restricted to for domain? I can only put what kind of numbers into arc sine? -1 and 1. And the range can only come out between where and where? -pi/2 and pi/2. There was 2's in there. Okay. What about arc cosine? Domain is the same. Range. What 2 quadrants are we looking in for arc cosine? the top two, 1 and 2. And then arctangent, all real numbers for domain, but 1 and 4 quadrants, 1 and 4, negative pi over 2 to pi over 2. Okay? That means we don't necessarily get a function with its inverse. X is my input and output. Remember we asked what would happen if I did arc cosine of the cosine of something like 5 pi over 3. Everyone got their circle on hand? Okay. So go to 5 pi over 3. Is cosine restricted? Just plain old cosine. Plain cosine isn't. Well, the range will be from -1 to 1, but domain is not restricted. I can go to 5 pi over 3. What is the cosine of 5 pi over 3? But then if I do arc cosine of 1/2, where do I have to look? I have to look up in quadrants 1 and 2, and I'm going to get pi over 3 instead of 5 pi over 3. So what we have to understand is that normally when I do the function of, the inverse function of a value, I normally get that value out. Now I'm going to say, not always, because arc functions are restricted. Okay? Now, they're going to have, not coterminal, they're going to have the same reference angle. They will always have the same reference angle. It's just we might have to go to a different quadrant because that's where it's legal. Okay? Example would be like, the background on my screen here is all the kids for Geekathon. I got to feed, 40 nerds. I'm probably getting pizza. But I have to go to Domino's because I've got like 5 kids who are allergic to gluten. So I have to go to Domino's every time because they got the gluten-free options. Okay? I'm restricted into where I can look for my answers. You are going to be restricted to quadrants 1 and 2 or 1 and 4. So we just got to be careful about that with all these. Sometimes, I'm actually going to go backwards order here. Do the sine of 7 pi over 4. First of all, regular sine. Is regular sine... Okay. Regular old sine, there's no restrictions on my input. Go to 7 pi over 4 and you get... negative root of 2 over 2. Now I do arc sine of that. Be careful. Yes, I'm in quadrants 1 and 4, but I label these from negative pi over 2 to 0 to pi over 2. So they're not just going to straight cancel and say 7 pi over 4. I have to say negative pi over 4. Remember that arc sine, negative 1 to 1 for domain, negative pi over 2 to pi over 2 for range. I can't get a 7 pi over 4 out because it's not in my available range. Yes, ma'am. Okay. Now, this was an interesting question that I had yesterday in third hour. What's a tangent of pi over 2? Undefined. What angle has a tangent of undefined? Pi over 2 and 3 pi over 2, right? Or, sorry, negative pi over 2 and pi over 2. is it possible to do this? Like, I can see where it is on my circle. If the tangent of this is undefined, and if I can look up where the tangent is undefined, can I get back to plus or minus pi over 2? Is it legal? What do you think? Since the tangent of pi over 2 is undefined, and I can look up where tangent is undefined, could I still answer this? Okay, y'all have a calculator? Let's try it. Right? The programming don't lie. Do the arctangent of the tangent of either pi over 2 or 90, depending on which mode you're in, and see if it'll allow it. Because intuition might say, well, it's here, and that's there, so answer. How many times in geometry did you just look at the figure and say, why do I have to prove this? Look at it. Right? That's why I said, could it be a plus or minus pi over 2? So here's why it has to work at every stage of the problem. The tangent of pi over 2 is undefined. And even though I can look up where the tangent is undefined a valid input? Is undefined part of the domain of arctangent? Okay, so it fails somewhere along the process. So I still have to say, no dice, doesn't happen. Okay? But that was a really good question that I heard yesterday about if that's legal or not. And that is also why our domain is all real numbers for arctangent, but my range is negative pi over 2 to pi over 2 with parentheses, because I can't go back to plus or minus pi over 2 because they're not included in the domain. Or sorry, the range. Okay, it was a really good question, just a point of clarification on it. Oops. This is not on my unit circle. This is why I wanted to do them backwards. Start with the circle, because we know that. Work our way backwards through the concepts here. Arcsine of negative 1/4. That isn't on my circle, but where is arcsine restricted to? Which two quadrants? 1 and 4. This has a negative sign value. Which quadrant is it going to be in? Okay, so I'll just draw a triangle down in quadrant 4. If you need me to put this here because it freaks you out, that's okay. And I will put a negative 1/4 for my sign value. So if I do the arcsine of this, I will get theta. I will get this angle. So what's the sine of theta? Negative 1/4, right? So this is what should happen whenever you compose a function with its inverse. The input should be the output, but it's not always going to work out that way. The answer is just negative 1/4. If you don't believe me, head over here. We're in degrees. Get out of there. So if I did the arcsine of negative 1/4, it's going to say blah, 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 angle. Okay, now if I take the sine of that angle, ta-da. Okay. That's because it put it in as a decimal. When I put this in, okay. Well, your jokes aren't very good because you're usually pedantic. So, those three, please. See, if you're always a troll, no one can tell when you're being a troll. Did you really just answer when I'm going to be a troll by being a troll?
Yes.
God. All right, bottom three. Look them up. Be careful about what is legal and what is not, which quadrants you're allowed to be in. Arc functions are restricted. Regular functions are not. Remember, don't just rely on the calculator for these. Sometimes calculator is going to send you on a wild goose chase. So.
That's negative sine, right? Or wait, I mean, whatever the heck that is. How do I know what quadrant it's in? I'm just keep getting.
Because arc sine can only be in quadrants 1 and 4.
Yeah, 1, 2, 3, 4, right?
Yes.
Yeah, so I chose that one. Is that right?
Isn't that a positive?
Yeah.
That's
so
why.
Up there. Okay.
Y'all don't know how happy it makes me to see all of these unit circles in pretty different colors and.
Mine's made in marble.
Okay, they don't have to be, but I like colors. Okay. Arctangent of pi over 3, is that legal? Remember, what is the input on arc functions? Angles or ratios? Ratios. So what they're saying here is there's a triangle such that opposite over adjacent looks like this. They're messing with you. They're trying to get you to go look at pi over 3 on the unit circle. The ratio is pi to 3. So now, that'll get me the angle. If I do the tangent of that angle, I'm just going to get pi over 3. Okay? Mm-hmm. Okay.
Because like when we're looking for pi over 3, it's like there, right? So then that's the tangent.
But the input is a ratio. You're looking at an angle when the input is supposed to be opposite over adjacent.
What do you mean? Oh, that's
Okay. Regular tangent has an input of angle, an output of ratio. So arctangent has an input of ratio, an output of angle. So when they said arctangent of pi over 3, they were putting in opposite over adjacent. They just happen to use a pi to throw a curveball at you. Pi is a number. The side length could have been about 3.14. It has nothing to do with the angle pi over 3. They gave you a... Okay. If I ask what angle has a tangent of pi over 3, it's going to spit out this. Okay, now what's the tangent of this? Opposite over adjacent. Okay, it's the throat punch Thursday thing again. Okay, every Thursday is throat punch Thursday. Hey Kevin, guess what? Right? It's the logical part of it that if I ask you your name while saying your name, I'm probably going to get your name as the answer. Okay? I did no such thing. If I don't observe something, I can't enforce it. Okay. Next up, cosine 3 pi over 4. This is same thing. Okay. Regular cosine, I put in angle. Okay, now I'm going to look at the angle 3 pi over 4. And it has a cosine value of negative root of 2 over 2. So now go do the arc cosine of that. Arc cosine is restricted to what two quadrants? 1 and 2. So you go look in quadrants 1 and 2 for who has this cosine value, and it happens to be 3 pi over 4 again. This is what should happen when I compose inverses. It's just not always going to happen that way because of restricted inverse functions. Like the last one. I just explained that whole thing, but you two were blabbing, so hit that video. The sine of 2 pi over 3, I go to regular 2 pi over 3, because sine is not restricted, and I get a sine value of root of 3 over 2. Now when I go do the arc sine of that, I got to be careful that now arc sine is restricted. So I'm only allowed to look in quadrants 1 and 4 for my answer. So I'm not going to get 2 pi over 3. I'm going to get 1 pi over 3 because they share the same reference angle. There is another one, but it's in one of the illegal quadrants. And then there's cosine values of its complementary angles. Yep, it's easy to go cross-eyed on those. Find the exact value of this. Now we're going to mix and match the different trig functions. So first up, it says arctangent. What's the domain on arctangent? All real numbers, right? Arctangent goes everywhere. So I know I've got a legal target. Where is my restricted output, my range, my answers? 1 and 4. So if I do the arctangent of a negative ratio, I'm going to get a triangle down in quadrant 4. Additionally, they just gave me opposite and adjacent. So I know I've got a 3, I know I've got a 4. Which of them gets the negative? I'm in quadrant 4, which is down. So there we go. Because arctangent is only in quadrants 1 and 4. And because these are the positive and these are the negative values, I know that since the tangent value is negative, my angle has to be down in quadrant 4. Okay, if I do arctangent of -3/4, it's going to give me this angle. It's going to be some decimal. But now I say go find the cosine of that angle. What is cosine? Adjacent and hypotenuse. So I'm missing the hypotenuse. I can do Pythagorean theorem or recognize a Pythagorean triple. 5. So now if I do the arctangent of this, I'll get theta. Okay, go find the cosine of theta. Adjacent over hypotenuse. 4/5. The arctangent is what gets me the triangle and the quadrant. You find the missing side, then you go do regular cosine like we're back in section 4.1. Okay? It's just we have learned enough about the unit circle, about negatives, meaning directions, about how all of these things interact that now we're able to start mixing and matching. It's kind of like you should know how to cook different things before you try to start a fusion restaurant. Okay? You should probably know how to cook chow mein and steak before you try doing a, right? Now, when you have those thin tender strips of steak and you put them in the chow mein, so. Oh yeah, sorry. People in South Dakota who are uncultured, wash your rice, for crap's sake.
Why wouldn't you?
That's actually gross.
It's a Midwest thing. People just don't know how, like, to cook rice, apparently. But yeah, but people don't. I don't know why. All right, do the thing. Speaking of tangents. Come on.
We said something like,
Come on.
Now, Village. Raj.
Do the problem.
It's a rebellion.
Yes, it is. 3, 4, 5, 5, 12, 13, 8, 15, 17 are the three most common ones. It's 20, 21, and something. I always forget what the third one is. That sounds better. Okay. Another thing about these, when it comes time for your quiz on Friday and your final, okay, that ain't too far off. 3 weeks from tomorrow. This is what I want to see in terms of reasonable work. Just show the stages, okay? You might be able to go straight to the answer by mental math, by looking around on your unit circle, or maybe you just got a calculator that'll do stuff for you. No. You get the review and whatever you can fit on it. Yeah. Because where is tangent positive? Where is arctangent restricted? You combine those two facts. Arctangent is only quadrants 1 and 4. Tangent is only positive in one of those. So I have to draw my triangle in quadrant 1. I just said that, but you guys were blabbing again. Okay, are we seeing a pattern here? Arctangent is restricted to quadrants 1 and 4. Of those two quadrants, tangent is only positive in quadrant 1. So I have to draw my triangle in quadrant 1. Tangent is opposite over adjacent. Y'all, I said, as long as we're attending to our responsibilities, I'll probably screw around more than you. I said that on day 1. But we have to attend to our responsibilities too. Okay? I get it. Believe me, I get it. It's getting nice out. We're towards the end of the year. Everyone's getting squirrely. We just got to lock it in for a few weeks. Almost there. Okay? Then Satan said, what if I took away all of the numbers? Write the tangent of the arcsine of A.
Wait, so like tan, art, A.
As an algebraic expression. So, no shaking and crying. Y'all, what is sine? Opposite over hypotenuse. How do I turn anything into a fraction? Putting over 1. Now, A could have been positive or negative. That will take care of itself. Well, it's a variable. I don't know if it's going to be in quadrant 1 or 4. But whether it's going to be positive or negative will shake itself out in terms of what the variable is. So I will draw an arbitrary triangle with a sine of A. A is A over 1. So where does A go? Where does 1 go? A is opposite. Can you do Pythagorean to find the missing side? It's going to be an expression. The square root of hypotenuse squared minus leg squared equals leg. 1 minus A squared. Do not try to pull a 1 or an A out of there because that's not a product, it's a difference. Okay? Are we okay to this point? All I said was arcsine of A I'm able to make a triangle and show you where that is. I'm able to do Pythagorean to the missing side. Now, go find the tangent of that angle. Tangent is what over what? Opposite over adjacent. So the tangent of that angle is going to be a over square root of 1 minus a squared.
But we can't.
No radicals downstairs. Getting kind of amped up over there, so I have to rationalize it.
I can tell.
So downstairs, we have just the radicand, 1 minus a squared. Upstairs, a times 1 minus a squared. Do I need absolute value or not? Do you remember the rule? Even root, odd power. So it was a even root. I took something out of square root, but it's not an odd power because whether a is positive or negative won't matter if I square it. Do you see how there's a singular a outside of radical town? There's a singular a that is not squared. So if a is positive, that'll put this triangle up in quadrant 1. And if a is negative, it'll put the triangle down in quadrant 4. So it'll take care of itself. I just drew this to wrap my head around it. Okay? It's not necessary. So you are starting, this is opening the gates, okay? You are ready for trig now. Almost. We're going to do law of sines and cosines again. When you go over to trig, you should now be able to start working with trig identities, where you can start replacing expressions with algebraic expressions. The sign of a thing can now be written like this. Okay, this opens the doors to trig and calc. Is what happens when I take away numbers. Can you still math with the variables? Okay, it's the same concept. You're doing the same stuff. It's just the training wheels are gone. Now this applies to everything instead of just that one example. Okay. Check with your neighbors, make sure you got stuff in the right spots. Then go make your expression. Double check on your Pythagorean. I know some of us are still goofing the whole do we add them or subtract them thing. That's why instead of just the formula itself, when I taught geometry, I always did leg is square root of hypotenuse squared minus leg squared. I always did them like that. Because A and B are arbitrary which one is which, because you're going to keep adding and multiplying things, and those are commutative.
And then you get. No, we got stuff for you. I knew it.
Okay. You start by creating your triangle, labeling theta, and putting your x and 1 somewhere. Okay. Depending whether it's arcsine, arccosine, or arctangent. You got to Pythagorean to find your missing chunk. I'll have a 1 minus x squared here, and a 1 minus x squared here. Then go find the other trig function that's the part of the composition. If I want the sine of this guy, opposite over hypotenuse is just a nice square root of 1 minus x squared, because it's that over 1. Cotangent, adjacent over opposite. No rationalizing here. It just is what it is. Yes, ma'am? I do because, so whether that triangle, like 8A, arc cosine could have been in quadrants 1 or 2, right? Depends whether that x was positive or negative. Well, if that x is positive or negative, whether the triangle is here or here, did that affect this? So it doesn't matter where I drew it, it was just a guide to help me through the problem. I have never been wrong by doing that. Yet. I can be wrong. I wish more teachers would tell kids that. We screw up all the time. Okay? I can be wrong. So far, I haven't been wrong doing that. But I might run into one of those problems that just, uh-oh, this don't work no more. So, there you go. Inverse trig functions. Ooh. Can you do it? Look around on your unit circle. I want to see if you can figure them out. This is the combination of it all. Some of it might be on a unit circle. Some of it might be you have to draw a triangle. Some of it might be restricted. Some of it might not. Hard to do it if you don't have a circle in front of you at all. Okay, we start with a whole bunch of arc functions. Arc functions are restricted. I'm either going to be in quadrants 1 and 4 or 1 and 2. Okay. They're just taking it in pieces here. I can do the arc sine of 1. Pi over 2, 90. I can do the arc cosine of 1/2. It's pi over 3, or 60. 90 minus 60 is 30, or pi over 2 minus pi over 3 is pi over 6. They're asking for the tangent of pi over 6. They just did it in a roundabout way. Square root of 3 over 3. And then this is just more of what we were doing before. Okay. Okay. So, everything sections 4.2 through 4.6 is using the unit circle at different applications, graphing based on it, and then we end off by flipping the script and going back to good old geometry. Please tell me, I know that most of you had a sketchy geometry experience. Okay. Did you do law of sines and law of cosines?
I don't think so.
Okay. So section 4.1 was all about right triangle trig. What happens when it's not a right triangle? Uh-oh. That's where law of sines and law of cosines come in. Okay. Law of sines says this is not a right triangle. Actually, it kind of looks like one. That looks like almost 90. Okay. We'll say that it's 93. All right. It is no longer a right triangle. So how do I start messing with it? Do you remember? Okay. Does anyone remember what this is called? The splitter. It is not an angle bisector or a perpendicular bisector because it doesn't cut the angle in half and doesn't cut the segment in half. What do you call the height of a triangle?
I know it, but I don't.
What is synonymous with height?
Altitude.
Altitude.
Ah!
Always turn your phones off before class. So I'm going to call that the altitude. I'll just put h for now. So in the space below this, you can write the proof for law of sines, and it's very simple. No, it's super simple. You better, because it was a geometry standard. You should be able to recreate this. If I asked you right now what the sine of angle A was, see how now I've made right triangles? Only look at the left-hand side. What's the sine of angle A? Okay. If I said, what's the sine of angle C? H over A, right? What do these two have in common? They both have an H. The angle A and side A, angle C and side C, swap, so I can't mess with that. Do you remember your alpha goldfish? Okay. Or swap your extremes, whatever your jam is. Here I have H is C times sine of A. Here I have cross multiply, and I'll get H is A times sine of C. So if H is this stuff and H is that stuff, they must be equal to one another. So if C sine of A equals A sine of C, I'm going to, if I divide both sides by C, C's cancel out. If I divide both sides by A, A's cancel out. And you get the sine of angle A over side A equals the sine of angle C over side C. And if I took this whole triangle and flopped it over so it was on the other side, I could redo the whole thing and find out it's also equal to sine of angle B over side B. That's the law of sines. The sine of any angle over its opposite side is the sine of any other angle over its opposite side. No. That was venomous. Okay. So law of sines is actually super easy to do. What you're doing is always looking for a control pair. You're looking for an angle and a side across from it. Because if you have one of these three ratios, you can cross multiply and solve to find the other ones. So if I ever have that control pair, I am good to go with law of sines. Okay? So, solve the triangle means you got to find everything. Always start with the easy part. I can find angle C, right? So over here I'm going to say measure of angle C is 180 minus 103 plus 35 is 138 is 42, meaning of life. Hitchhiker's Guide to the Galaxy, either watch the movie or read the book. Yes.
Read the book or watch the movie. It's that simple.
There's no that's the name.
Okay. So I found one of the three things. I don't need to split it because I don't need to reinvent the wheel. I've got law of sines now. Do I have a control pair? An angle across from its opposite side? The B's. So I can now say the sine of 103 over 20 is, switch colors. Go tiny. The sine of 42 over C and, no, not that color, we'll go yellow. A over A. I also have sine of 35 over little a. Start cross multiplying and solving. If you need to separate that into two different ratios because that's just too much stuff going on at once, that's okay. This is sine of 42 over C equals sine of 103 over 20, and sine of 103 over 20 equals sine of 35 over A. Now you either cross multiply, divide by whatever's in front of your variable, or, been trying to show you for the whole semester if you didn't have me before, multiply the two that line up, divide by the one that doesn't. Yes. It's the alpha fish, the goldfish, the Jesus fish on the back of Karen's van. C is 20 sine of 42 over sine of 103. And did I run out of colors? I think I ran out of colors. Oh no, we got red. Multiply the two that line up, divide by the one that doesn't. A is going to be 20 sine of 35 over sine of 103. Sine 103. There we go. Now those are the expression answers. If I say, how far is it from this house to that house, and you say 20 sine of 42 over sine of 103 miles. No one getting that. So next to each of these, give me their decimal approximations. Okay, how about A? Ooh, what mode should we be in? Should be in degrees because I was given degrees. So I'll say A is about how much? Just based on proportions here, I would bet it's what, like 7, 8? Six? I don't know, I'm guessing here. A, how big A? Oh, wow. 7 who? And C. Okay, before I even find it, should it be bigger or smaller than that one? Because bigger angles, bigger sides. You said it was 13 something? Okay. This is what you did in geometry. I don't know if you did the ambiguous case in geometry. That's where we have two different triangles possible. So, to be continued. Who sings that?